faster because here we're just focused on graphing and identifying key features. Okay, so again, we are talking. This is our third video in the Module 3, Lesson 8, where we are graphing using standard form. See, standard form. Okay, so remember for that standard form, we want to find that vertex first. Okay, and the vertex is located, the x-coordinate is located at negative b over 2 times a. Or in this case, negative 6, right, because there's our b, over 2 times a. And the a here is a 1, right? It's not written, but we know it's a 1 there. So negative 6 becomes positive 6 over 2, which is just 3. To find the matching y value for the vertex, right? So now we know the vertex is 3 comma something. We'll put 3 into the function. So n of 3 equals 3 squared minus 6 times 3 plus 5. So that's going to be 9 minus 18 plus 5. So it's going to be negative 4. So 3, negative 4 is going to be our vertex. Now we can create a table. Put that 3, negative 4 in the center of the table. Let's just pick some points before 3, so like 2 and 1. And let's pick some points after 3, so like 4 and 5. And we'll just plug these coordinates into our function here, okay, get the matching y values. So let's plug in a 2. Okay, so 2 squared minus 6 times 2 plus 5. Okay, we'll get 4 minus 12 plus 5, and so that's going to be negative 3. Okay, let's do the same thing here for 1. N of 1 equals 1 squared minus 6 times 1 plus 5. So that's going to be 1 minus 6 plus 5. 1 minus 6 is negative 5 plus 5 is 0. Hey, that's nice. Okay, why don't you go ahead, pause the video, and do these other two right here for 4 and 5. Okay, hopefully you took the time to do that, plugged them in. For 4, you should have gotten negative 3, and for 5, you should have gotten 0. Okay, you'll notice the symmetry here in the table. Makes it kind of helpful when it comes to graphing. Okay, I'm going to go ahead and keep the y-axis here and the x-axis here for this graph because in this case we don't really have a context, so we're just going to graph it. So let's see here, 3, and I'm just going to say that we're counting by 1s here and counting by 1s here. So I'm not going to label anything, we just know we're counting by 1s. So again, there's the x-axis, there's the y-axis there. So 3, negative 4. Okay, there's our vertex. How do you expect this graph to curve? Do we expect it to curve open up like that, or do you expect it to open down like this? Look at your a value. What do you say? The a value is positive 1, right? So we expect it to curve up like this. Okay, so let's see. 2, negative 3, and also 3, negative 3, or sorry, 4, negative 3, 1, 0, and 5, 0. Okay, you can get more points if you want to. So for example, I know the y-intercept is at 0, 5, again, just because it's in the standard form there. So 1, 2, 3, 4, 5. And then by symmetry, we'll also have this point too. Okay, and that's probably enough for right now. We can just connect those dots. Doggone it. There we go. Okay, so key features. Let's do domain. What's a domain? What's the farthest left? What's the farthest right? Negative infinity to infinity. What's the range? Well, what's the lowest y value you see here? Lowest y value is this y value right here at the vertex, so negative 4. Highest y value, it's going to go to infinity. Okay, we can talk about the zeros, right here where it crosses the x-axis. Those are actually things we calculated, so it's the points 1, 0, and 5, 0. Alternatively, you can just say x equals 1, x equals 5. The y-intercept, right, we found that too. It's just at the point 0, 5. Okay, we can talk about increasing, decreasing, and behavior. So all those things too. So I'll just do this. When is it increasing? It's for this portion of the graph, right? Starts at the x value of 3 and to infinity. Where is it decreasing? From negative infinity to 3. Okay? And behavior, as x approaches infinity, that means as we go really far to the right, we're going up, right? So the function n of x approaches infinity. As x approaches negative infinity, n of x approaches, well, as we go to the far to the left, we're also going up still, so it goes to infinity as well. Okay, so there's our end behavior. All right, pause right there, and we'll come back to another video.